Welcome everybody, and thank you for your interest. Now I'm going to show you a basic class on the use of Stata using an example, which is a panel data example. This is not a full course on Stata, and it's not a full course on panel data. Is just an example that comes with the rest of the course, and it's just a complement and not a substitute with the rest of the course. Here in this particular transparency number 2, you see the content of the course that I'm going to give you here. This is first we see the Stata user interface, how to open a dataset, how to explore, make a basic exploration of the dataset, and then go to the estimation of a simple model, which is the pool model, then declare a dataset to be a panel, and then explore the dataset when it is a panel, and at the end we're going to do some estimation using a fixed effect model, a random effects model, and then a Houseman test. It is important to remember that we are going to be working with the menus and not the commands, because in general you don't know the commands, and the menus give you a lot more flexibility and options. Second, I want to stress that we are going to use a do file, and the do files are very important because they are going to be a record of the successful commands plus the comments that you want to, the documentation that you want to use for your own benefit. It is very important and very useful, and there's no substitute to doing a useful and very well documented do file if you want to use Stata. First, I want to show you the Stata interface, which is this that you're seeing here, and this is a very unappealing interface, I would say, but it has all the elements that are needed. First, on the upper left hand side you have the all the options bars, and then you have 4 main windows. The bigger one, which is in the middle, is the results window. You will see here everything that you have been doing. It comes out in that window. And then you have the variable list window, which is on the right hand side, and that is the description of the data. Then you have in the lower part, right hand side part, you have also some description of the data. On the very left hand side, what you have is the compilation of all the commands that you have been using. If you use commands using Windows, you will get the exact equivalent to that in that window in terms of commands, full commands. And then on the lower center, you have the command window in which you can type if you want commands, and you can use that window to do the recycling of previous commands. Typically you use the same command many times, or you use slight variations of the command every time. So you can change that, you can amend your own commands in that particular window down there, the command window. Now in this new slide, what we see is different examples of different options that you get when you hit the options bar on the upper left hand side. You see, if you hit file, you see a lot of things that you can do with the files. If you hit graphics, what you see is a lot of options that you have, different type of graphic, two-way graphs, bar chart, dot chart, pie chart, histograms, and many other types. If you hit one of these, you will find a lot more options and a lot more possibilities until you get the option that you want to use. And again, working by Windows and options menus, then you go to the right hand side and you will see that if you hit statistics, you will see that you have a lot of different options there. You have a summary statistics, linear models, time series, and then we want to concentrate in the longitudinal panel data option, from which a lot of other possibilities hang if you hit there. So this is a menu in which you see all different possibilities. If you hit each of these, you get a lot more possibilities, a lot more options that you can use. So this is a simple but a very effective way of starting to use Stata. Our next task is going to be to open a data set. We are going to assume that we have a data set that is already in .dta format, in Stata format, and all we need to do is just open it and use it. If you don't have the data set already set up, what you need to do is to read it, and many times you can just cut and paste from Excel. So that is something simple and useful if you want to enter data into Stata. If you want to open a data set like you have here in this transparency, where you go to the open option up there, and then you get the window in which you see the data files that you have in Stata format, and then what you need to do is just choose the file that you want to use and open it using the appropriate option. So this is something that you have done many times, nothing special, and it works the same way as usual. When you open a data set, what you see is the following. You see that the new data set is available because in the variables window you see the names of the different variables, and also some label, some description of what it is about. And it is very useful to know that if you go if you open that window, you may get even more explanation. So that is very useful. Now in the middle, what you see is the output that you have done. You see first the command that you have used, and on the left hand side in the command window you see the same command there. You have to remember that this command window is going to be very useful because you can recycle the commands that you have used, and also because you can cut and paste this into the do file, and that is something extremely useful and that you want to do all the time. You don't have to cut and paste every time. You can cut and paste at the end if you want, at the end of the Stata session. In this section we are going to see how to do some basic data exploration, which is very important, very useful, and something that you should do all the time. You have to know your data very well, and it's going to be a simple and fast task to do with Stata. You see in this transparency number 9 that we can use the menus again to go to statistics, then summaries, table and test, and then graphics, and we will do all these different options, and the options will lead you to use some specific commands like describe, summarize, tabulate, histogram, scatter, and two-way scatter. And the idea is that if you go by menus, you're going to reach options like these that you see in this slide. You can tabulate your data, you can do histograms or plots. Let's see that in the next few slides. In this slide you see that we have tabulated the variable expert, which is experience, and in this particular variable what you see is the values that this variable takes and the frequency that it takes. So this is a simple description. You also see if you use the variable tabulate and use black, you see essentially how many non-blacks and blacks you have in your sample. So this is a basic and useful description of the data, one variable at a time. Then you can also use some other variables to do like a histogram, which is we are going to use education. It shows you how many times a given value appears in the sample, and you get the histogram on the left hand side of the screen. Now if you use also the graph option, you can do graphs of the variables, say for instance the logarithm of wage against the years of schooling, and then you get a graph like this, which is sometimes hard to interpret, but if you use a line, which you can do very easily using the commands that are in the options of the window, you can see that it helps you a lot to see the relationship that you have between the two variables. And you can use all other options just to go through your data set and get to know the different properties of the variables that you have in your data set. Now in section number 4 we are going to use a basic regression model, which is the pooled OLS model. It's just ordinary least squares model on the whole sample without telling Stata that it is a data set, a panel data set, just using it as if it was a cross-section. In this slide number 13, what we see is how to run a simple regression using this data set that we have here. You go to the statistics and then the options of linear models and related models, and then linear regression, and then you go to the this dialog box on the right hand side, and you see that there are many different possibilities. You can click on each of the possibilities and see that there are a lot of possibilities in this data set. for using commands in this data set. You have to input the dependent variable and the independent variables, and that is easy to do by selecting the appropriate variables from the list, the fold down list that appears. And then you hit OK. What you get is the following table. In this table, in slide number 14, what you see in the middle, in the upper part of the middle window, you see the specific and exact command that you have used. You remember that we have gone through Windows, but this is the exact equivalent of this particular command to the Windows option that we have used. You see that this appears here in the middle, and also in the left hand side it appears again. If you see the output that we get, this is a basic regression output, nothing special. The number of observations is 4,360, and then the F-test is a test of joint significance of all the variables used, which is 51, and that is above the critical value. The critical value is around 2, so it is above, meaning that we have a significant a model which is significant. Then the p-value of that 51, that tells you the probability of getting a value higher than 51 just by chance, which is 0. And then the r-square is the percentage of the variation of the dependent variable that is explained by the linear association with the variation of the independent variables. Adjusted r-square is a penalization of the above criterion by penalizing the number of variables that it's using, by the number of variables that it is using. And then if you go down in that output, you see that you have a column and that starts with L wage and then goes back to black, Hispanic, expert, expert square, married, union. Those are the variables that we have chosen to use in this particular example, and those are variables that may or may not be significant. Please notice that all of them except possibly Hispanic, the second explanatory variable, HISP, are significant. So it is interesting to see that we have a model already which is jointly significant and individually significant. It need not be the good model, the best model, but it is a model that is decent at least. In this section 5, what we're going to do is to declare a data set to be panel data. The reason is that sometimes Stata doesn't know that we are using panel data, or it stops recognizing the data set as panel data. This is why I want to stress this here. If you want to do that, first you go to statistics and then go to longitudinal panel data, then to setup and utilities, and then declare data set to be panel data. It is important then to know which is the panel ID, that is the ID that distinguishes one individual from another, and then also the time variable, and that is going to tell us which year is which, or which period is which, and that is what you have to say and input here, so that Stata knows that is going to be a panel data and can treat it appropriately as panel data. The output of that command is the following. You see that the command is xtset nr and then space year, and that is appears in the upper and center window. It also appears in the left hand side, and it has been typed again in the command window. It is very important to notice that this happens sometimes. It happens that Stata cannot distinguish a panel, and then you have to tell Stata that it is effectively a panel. Then let's see some commands that are useful for panel data exploration, which are similar to the previous ones, but with some differences. Again, we are going to go to statistics and then longitudinal panel data, setup and utilities, and then you see the commands. Those commands are all of them start by xt. Xt means cross, and x means cross, and then t means time series. So it is cross section and time series data, which is the panel data. That is why the xt in front of each of the commands. You can use help xt to know what's going on and understand what's going on. And by the way, help is very useful in Stata. It is very detailed. Sometimes it is too detailed, but it is extremely useful. What I recommend is, if you don't want to read everything about the help of a given command, you go to the examples that are in the bottom of the documentation, and typically you can do well by using one of the examples that are given in the bottom. So you don't have necessarily to read each one of the options carefully, but rather go straight to the bottom. You see all the possible options that you have: xt describe, xt summarize, and xt tab, xt trans, and xt line. Those are options that you may want to use. You can use them by yourselves. I don't have to tell you everything about each of them, and they are extremely useful. Then if you use some of those, like xt tab black, you get again a description of the variable with some more detail than before that you can see by yourselves. And it is now recognizing that we have 545 individuals that are observed along the whole time period. It is a strongly balanced data set. Now what we want to do is, using the data set that we have been using up to now, estimate it using now panel estimation techniques. And the first thing we're going to do is use a fixed effects model. If we want to use a fixed effect model, what we want to do is you go to statistics, then longitudinal panel data, linear model, and then linear regression. And if you fill out the variables that are going to be used in the appropriate dialog box, then we can do as follows. You see now what I was telling you. You see the log of wage, which is a dependent variable. Then you have the explanatory variables, education up to dummy 81 through 87, and then we are going to start estimating by using the simple model and a simple estimation technique. The simple model is a fixed effect model, and the estimation technique is a ordinary least squares with dummy variables. If we do that, we are going to see what we get. We get an estimation here in which we have a higher R squared than before. We have the number of observations there, the number of groups, which is in this particular case the number of individuals, which is 545. Then the observations per group, they are 8 in total. A maximum is 8, minimum is 8, and it is a strongly balanced data set. You see, then the F test is a test of joint significance, or all the variables in this model except the constants, and it is has 10 degrees of freedom in the numerator and 3805 in the denominator. The value is, the computed value is 83, and you see there with a p-value of 0, that is telling us that the probability of finding a value larger than 83 by chance is 0. So that means 83 has not happened by chance, it has happened by some systematic behavior that we are looking at here. You see that education, black, expert square, married, union, those variables are important in this particular model. There are 3 variables that have been omitted. Omitted means that they have not been used in the estimation, and that is because those do not change within an individual a long time, and that's why they have been omitted here. You also see that the variable D87 has been omitted because to avoid collinearity here, and in the lower part you have a test of basically heterogeneity by testing whether the constants are all equal across the individuals or they are different. The F test is computed to be 9.64. That is highly significant, as you can see in the p-value of the F, which is 0.0000. It is highly significant. It is very unlikely that you get a value as high as 9.64 just by coincidence. Now let's see how we can estimate this model using a different approach, and that is the random effect model. The random effect model is going to be estimated using generalized least squares instead of ordinary least squares, and with the generalized least squares we are going to get these estimations. You see that what we need to do is again go to statistics, longitudinal panel data, linear model, and then linear regression, and then you go to the dialog box and fill in the appropriate values or names of the variables. You see again the dialog box is telling us what it is, the basic model that we are using. We are now estimating it using generalized least squares, and then we hit return and see what the estimation of the model is. The estimation of this model is similar to the previous one in terms of the table that we see, but it has changed some of the in important ways. You see that education, black and HISP now its effect can be estimated, and its effect is positive or negative depending in which case, and it is like more rich than the previous one. So in principle, if we can use this model, it would be better, because it is estimating now the effect of 3 variables that we could not estimate in the previous one. So now let's see also that we have a world chi-squared of 14. This is again a test of joint significance of all the variables in the model, and it is highly significant with a p-value which is 0.000. You see the r square is, the overall r square is 0.18, which is high for this particular type of data sets. And now finally we're going to look at the Houseman test. The Houseman test is a test that is going to help us deciding which estimation technique we want to use if we are using the random effects model. It is going to help us decide between OLS and GLS. The Houseman test can be easily done by using the commands, because I find it more easy to do using the commands than using the windows. So you just write the estimation by fixed effect, and then tell Stata to keep the estimates that it has produced under the name FE, and then estimate again using the GLS technique, and then you can keep them under RE, or you don't need to keep them, and then so that line can be done without a fourth line, and then use Houseman FE to just without necessarily using the RE. You can also do without the RE, and the Houseman FE will give you the Houseman test. The Houseman test, it is complicated at the beginning, but if I explain it, you will see that it is quite intuitive and useful. Now we are showing here how to estimate how to compute the Houseman test, again using the windows, which is something that you can also do. So you can do whatever you want. You can do commands or windows, but in any case what you get is the same output, of course. Here you have the command and also the output for using the Houseman test. You see that in this case you have the coefficients estimated both by OLS and GLS. The OLS are those under the column FE, and the GLS are those under the column of RE. The differences between the two estimates are in the third numerical column, and then an approximation of the standard deviation, which is not the standard deviation but just suggestion, is in the last column. There are a lot of dots and those are telling you that Houseman test is not comparing those variables and those coefficients, because it doesn't really make sense to compare them. And then what you get down here is it has been computed as a chi-square t, chi-square of 10 degrees of freedom, and the idea is that if that number is very high, you would have to reject the null hypothesis of no correlation between excess and individual effects, and that in that case, like here, you have a very high value, you would not be able to use generalized least squares, and you should use ordinary least squares. So this is the help that you can get from the Houseman test.